Welcome back to your solutions. We're doing question 1 now, and we need to sketch the locus of the point P that has a distance from the x-axis. Well, let's first of all set up an axis. You don't have to use a ruler, it's always nice to. And we want the distance from the x-axis that is 3 times the distance from the y-axis. So imagine I've gone 1 unit from the y-axis, I need to be 3 units away from the x-axis. So this point here, which is the point 1, 3, would lie in my locus. Don't forget to label your axes. Another point that would lie on the locus would obviously be 0, 0, because 3 zeros is 0. And I'm pretty well guessing it's a straight line, and you all seem to know that. Don't forget that I could go in the opposite direction. I could actually have this going in that direction as well. So a positive slope line and a negative slope line. 1 point on that, and I'll also represent another point on the other side, which would be the reverse minus 1, 3. Part 2 says, hence write the equation of the locus, and that was Twitter, great. And hence write the equation of the locus, and the locus is, well, y is simply plus or minus 3x. Part B, for the parabola x squared plus 6x minus 12y plus 3 equals 0, we're asked to find the coordinates of the vertex. So this requires us to complete the square and to recognise what form. Now it's an x squared equals 4ay, and you get to slide in your vertex. So what I'll do is I'll put all the x terms on one side and all the y terms and the constant on the other, and complete the square. Halve it, square it, and keep it balanced. So the left hand side will be x plus 3 all squared, and that's equal to 12y plus 6. We need to take out the coefficient of the 12, so that's y plus a half, x plus 3 all squared. So my vertex can be simply read off now as the point minus 3 minus a half. Now asked to calculate the focal length. Well, 12 represents 4a. So for part 2, 4a equals 12, and my focal length will be 3 units. So focal length equals 3 units. And the last part of the question, and I hope you saw that, seeing as it didn't have the number 3 next to it, said find the coordinates of the focus. Now recognising that it's a concave up parabola, and it's x plus 3, so vertex will be at minus 3 minus a half, concave up. So my focus will be 3 units up from my vertex, which was minus 3 minus a half. So my focus, which we represent with the letter S, will be the point minus 3 moving along that axis, so the x ordinate doesn't change, but moving up 3 units, so that will be 2.5. Part B of that question? No, that was part B, this is part C. States 2 parabolas have their vertex at the origin, a horizontal axis. So having a horizontal axis means they'll be sideways parabolas, both of them, and both of them have vertex at the origin, and they will go like this. You'll draw yours much better because you'll have your mathematics handy. Mine's in my desk at work. The other piece of information was that the latus rectum was 8 units in length. So putting my latus rectum in here, we know that that passes through the focus, which we'll call A, and because it's 8 units in length, it will have coordinates A4 and A minus 4 on this parabola. And if we put our other latus rectum in, we'll have coordinates minus A, minus 4, and minus A4. And that will be the diagram that you will need to draw. Now we need to determine the equations of these two parabola, and they'll have the form y squared equals 4ax, that's your sideways parabola. And we do have a point that fits on there, that's the coordinate a4. And through substitution, y squared, 4 squared, which is 16, equals 4 times a, and my x ordinate is a. So we'd have 4 dividing by 4 both sides is equal to a squared, or a is equal to plus or minus 2. Therefore the equations are y squared equals plus or minus 4 times a, which is 2, so that's 8x. Y squared equals plus or minus 8x. Part D of question 1 for the line 2x plus y, 2x plus y minus 15 equals 0. This will cut the parabola x squared equals 12y in 2 points P and Q. By solving simultaneously, show that the points of intersection are 6, 3, so we're aiming for 6, 3, and minus 30, 75. Solving simultaneously, we'll need to substitute in. We could substitute this one into the equation, so I'm going to make that y is equal to x squared on 12. There's many ways we can do it. I'll choose this one. 2x plus y, so plus x squared on 12, minus 15 is equal to 0. I'm hopeless at multiplication. 12 times 15, turn it on, 12 times 15, and it's got fat batteries. Try another one. 12 times 15, 180. So we have x squared plus 24x minus 180 equals 0. And hopefully that's going to factorise with x, 6 and 30. And 30 minus 6 is your 24, so it's going to be x minus 6, x plus 30 equals 0. Therefore my x ordinates are 6 or negative 30. If x is equal to 6, we need to do a substitution. Y will equal 36 on 12, x squared, 36 on 12, which is 3. That fits that coordinate. And if x is equal to minus 30, y is equal to minus 30 squared, which is 900 on 12. And hopefully that division, 900 divided by 12, gives me the answer 75. Excellent. Therefore, 6, 3 is P, and Q will be minus 30, 75 as required. We're asked to continue on with that question, and it says, show that the equations of the tangents at P and Q intersect on the line y plus 15 equals 0. Alright, well a tangent, the first thing you think of is calculus. And so if the first thing you think of is calculus, we firstly need to have what the equation is. X squared equals 12y. I'll need to put that in the form of y equals x squared on 12. And we'd like to look at what the gradient of the tangent is. And to do that we need y dash, or do y by dx. And that's 2x on 12 or x on 6. Now we've got two sets of coordinates. One was 6, 3, and the other was minus 30, 75. Now at x equals 6, the gradient of the tangent will be y dash equals 2 times 6 on 12, or simply 6 on 6, which is just going to be 1. So the equation of the tangent at the point x equals 6 is going to be y minus y1, or y minus 3, equals m, the gradient of the tangent, outside of x minus x1. So y is equal to x minus 3 if I take the 3 across, so it'll add the 3 to the other side. we'll make that equation 1. Actually, I'm actually going to rearrange that to be x is equal to y plus 3, because we only really need to find, our aim is to show that the point lies on y plus 15 equals 0, and all we need to do is to show that y equals 15 or negative 15, and that will actually be our result. So I don't need to eliminate y, I will need to eliminate x further on. The second point, at x equals 30, x equals negative 30, y dash, the gradient of the tangent will be negative 30 on 6, or negative 5, and the equation of that tangent will be y minus y1, y minus 75, equals m, the gradient of the tangent, outside of x minus negative 30, so that will be x plus 30. So y minus 75 will equal negative 5x minus 150. We're going to add 150 onto each side, and I'll have, well actually I won't do that, I'll say y is equal to negative 5x. We're going to add the 75 onto this side, so that's minus 75. That's my second equation. To find the point of intersection, I'm actually going to substitute in for x, and x would equal y plus 3. So y is equal to negative 5 lots of y plus 3 minus 75. So I've substituted y plus 3 in for x. Y is equal to minus 5y minus 15 minus 75. Adding this across, 6y, and that's going to be 90. And I'm guessing when I divide by 6, the result will be 15. So minus 90 minus 15, and that's the aim. We wanted to show that y lay on the line, well the point lay on the line y plus 15. In other words, the y ordinate was negative 15, which is what we wanted. So we make a statement, therefore the point of intersection lies on the line y plus 15 equals 0. We weren't even asked to find the x ordinate. That's the end of question 1, I think. Finished.